Pluto, heart of ice at the edge of the sun. For most of the 20th century, Pluto was a mystery at the edge of the map, a tiny moving point of light, colder than anything we could imagine, and too far away to see clearly. We called it the ninth planet, then a dwarf planet, then almost forgot about it as our attention turned to worlds closer to home. But in 2006, the same year we reclassified Pluto, NASA's New Horizons spacecraft began a journey that would change everything we thought we knew about this distant world. Imagine riding with that spacecraft. You leave Earth on a column of fire, accelerating faster than any probe before it, over 50,000 miles per hour, fast enough to pass the Moon in just 9 hours. You slingshot past Jupiter, stealing a little of its orbital energy, and then you coast outward for nearly a decade into a deep, dark cold that no human has ever experienced. As you travel, the sun shrinks. Near Earth, it blazes as a blinding disk, lighting up blue skies and bright clouds. By the time you reach Pluto's orbit, the sun is just another brilliant star in a black sky, and the sunlight is hundreds of times dimmer than what you feel on a cloudy afternoon on Earth. Here, the average surface temperature falls to about negative 390 degrees Fahrenheit or negative 235 degrees Celsius, so cold that ordinary water ice is as hard and rigid as steel. For decades, Pluto was little more than a blurry smudge in our telescopes. We could measure its size, estimate its mass, and guess that its surface was made of frozen gases like nitrogen and methane, but the details were hidden in darkness. All of that changed in July 2015, when New Horizons finally raced past Pluto at more than 30,000 miles per hour, snapping images and recording data during a flyby that lasted just a few hours. The first close-up pictures were astonishing. Instead of an old crater-scarred ice ball, Pluto revealed itself as a geologically active world with mountains, plains, glaciers, and a complicated atmosphere. Front and center, stretching across one hemisphere, was a vast pale shape that instantly captured our imagination, a bright heart-shaped feature now known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The western lobe of this heart is a smooth, brilliant plain called Sputnik Planitia. At first glance, it looks like a frozen lake, but New Horizons data showed that Sputnik Planitia is actually a gigantic glacier made mostly of nitrogen ice, mixed with carbon monoxide and methane, hundreds of miles across and up to several miles thick. Its surface is broken into polygonal cells, each tens of kilometers wide, probably formed by slow convection, warm ice rising, cool ice sinking, like the churning of a pot, but in ultra-cold, exotic ices instead of water. Even more surprising, Sputnik Planitia is almost completely free of impact craters. In the outer solar system, a lack of craters means the surface is young and constantly renewed. Here, more than 4 billion miles from the Sun, Pluto is still reshaping itself. Nitrogen glaciers creep, ices flow, and the landscape is being erased and rewritten on geological timescales. On the margins of this nitrogen sea rise jagged mountains, some towering up to about 3 to 4 kilometers, roughly 10,000 to 13,000 feet above the surrounding plains. These peaks are not made of silicate rock like on Earth. Pluto's bedrock is water ice. At these frigid temperatures, water is so stiff and strong that it can form cliffs and mountain ranges, serving the role that rock plays on our planet. Scattered across Sputnik Planitia, New Horizons found isolated hills and blocks, some as large as major city centers, floating in a sea of nitrogen ice. Because water ice is less dense than solid nitrogen, these blocks behave like icebergs, carried slowly by the glacial flow and piled up along the basin's edges. It is as if an entire mountain range had broken loose and begun to drift inch by inch across an alien frozen ocean. Pluto's colors are just as dramatic as their shapes. Although much of Sputnik Planitia is bright and almost white, other regions of Pluto's surface are tinted in shades of red and brown. New Horizons revealed hazes high in Pluto's thin atmosphere, produced when ultraviolet radiation from the distant sun break apart nitrogen and methane molecules. These reactions build complex organic molecules called tholins, sticky carbon-rich particles that slowly fall out of the sky, coating the surface with a dark reddish film. This same process helps color Pluto's north polar regions and some of its craters and valleys, giving the world an irregular, patchy appearance. It may also be responsible for the dramatic dark cap on the north pole of Pluto's largest moon, Charon, where gases escaping from Pluto's atmosphere freeze and gradually transform into red-brown tholins under radiation. Perhaps the most breathtaking image of Pluto came not from the approach, but from the moment after the flyby, when New Horizons looked back. Silhouetted against the distant sun, Pluto appeared surrounded by a delicate ring of light, a thin, glowing atmosphere wrapping the dark disk. When scientists processed the colors of that haze, they found something no one expected at the edge of the Kuiper Belt. Pluto's sky is blue. The particles in Pluto's atmosphere are probably gray or reddish, but they are so small that they scatter blue light more efficiently, just as molecules in Earth's air make our sky blue. The result is a ghostly layered halo, multiple thin haze layers extending more than 200 kilometers above the surface, likely formed as gases rise, cool, and condense into icy particles. For a brief moment, as New Horizons passed through Pluto's shadow, we saw that distant world not as a point of light, but as a place with a sky. Hidden beneath Pluto's frozen shell may be another surprise. To explain why the heavy nitrogen glacier of Sputnik Planitia sits where it does, and why Pluto has not rolled over to reposition this heavy basin, scientists propose that Pluto harbors a deep subsurface ocean of liquid water beneath its icy crust. This buried ocean would be kept from freezing solid by a combination of internal heat from radioactive elements and insulating layers above it. If this ocean exists, it would make Pluto one of several worlds in the outer solar system, like Europa and Enceladus, where liquid water may persist underneath an icy surface. We do not know if such an ocean could ever support life, but the possibility raises profound questions. Even at the edge of the sun's influence, conditions may exist that are more complex and perhaps more habitable than we once believed. Pluto's story is not complete without its companion. Orbiting just 19,000 kilometers away is Charon, a moon so large, about half Pluto's diameter, that the two bodies form a true binary system, each orbiting a shared center of mass that lies in empty space between them. Both Pluto and Charon are tidally locked, always showing the same face to one another, so that from one hemisphere of Pluto, Charon never moves in the sky, and from the other hemisphere, it never appears at all. Charon itself is a rugged world, with canyons deeper than the Grand Canyon and smooth plains that hint at past geological activity. Its north pole is stained by a dark reddish region informally nicknamed Mordor Macula, likely formed from Pluto's escaping gases that froze onto Charon and were chemically transformed by radiation. Around this central pair, four much smaller moons, Styx, Nix, Kerberos, and Hydra, tumble in complex, chaotic rotations, their motions shaped by the combined gravity of Pluto and Charon. Today, Pluto and Charon are the most famous residents of the Kuiper Belt, a vast ring of icy bodies beyond Neptune. These distant worlds are thought to be leftovers from the formation of the solar system, time capsules that preserve the original ingredients from which planets were built. By studying Pluto up close, New Horizons has given us a window into this ancient reservoir and shown us that even small, distant objects can be surprisingly active and diverse. It is easy to focus on Pluto's changing status from planet to dwarf planet and forget what truly matters. In terms of physics and geology, labels do not change the reality on the ground. Pluto has nitrogen glaciers, water ice mountains, an evolving atmosphere, and possibly an internal ocean. It is not a dead rock. It is a dynamic world, still reshaping itself in the deep cold long after the giant planets finished most of their evolution. New Horizons continues its journey through the Kuiper Belt, exploring other small worlds, but its brief encounter with Pluto has left a permanent mark on planetary science. We now know that complexity is not reserved for large planets close to the Sun. It can also thrive in the darkness, where exotic ices flow like glaciers, thin hazes build blue skies, and chemistry slowly paints the ground in shades of red. So the next time you hear that Pluto is just a dwarf planet, remember the reality. At the edge of our solar system, more than 4 billion miles away, a small world with a bright icy heart, drifting mountains, strange chemistry, and a possible hidden ocean continues its silent orbit around the Sun. Pluto does not need our validation. Whether we call it a planet or not, it remains one of the most beautiful and surprising worlds we had ever seen. A frozen frontier that reminds us how much is still waiting to be discovered in the dark.